Hi, Assalamualaikum. My name is Nur Aisyah Mira Mitima Isa. My metric card number is CF200029. So, I am from group 10 and my group will explain about the partial derivative. First thing first, I want to introduce about my group member. First, Nurlisa Khalida binti Hasrin, Nurul Farahanis binti Mizlan, Nurul Nadia binti Mak Jusso alias Muhammad Yusof, dan lastly Nur Shazana binti Ma'ruf.
Assalamualaikum, my name is Nurul Farahanis binti Mizlan, my metric number CF200181. I would like to present about the introduction for this project. The partial derivative of a function with many variables is its derivative with respect to one of those variables, while the others are maintained constant in mathematics, which is as opposed to the total derivative in which all variables are allowed to vary. In vector calculus and differential geometry, partial derivatives are utilized. It has studied differentiation for a single variable function in secondary school. It will now differentiate a function of two or more variables, a process known as partial differentiation with partial derivative denote. In partial derivative, use the partial differentiation operator delta over dx or delta over dy and the subscript x or y instead of dy over dx or y prime for the derivative of single variable functions. In many circumstances, the partial derivative may be computed simply using the derivative method for a single variable function. The first partial derivative, for example, might be described in terms of limit. Any variable other than x or y is treated as a constant in the more convenient method of finding partial derivative, fx or fy.
The objective of this project is first one to make sure that students are more exposed with real-life application that related with the topic, which is partial derivative. Second is to get more detailed understanding with the topic of the project. The third is students can be more improved in solving problem scale.
Next, for the problem statement, for the question 1, is the radius of a right circular is measured with an area of at most 2% and the height is measured with an area of at most 4%, approximately the maximum percentage error in the volume, which is P. So as we know that the volume for cylinder is pi r squared h, the question given is for the percentage error for the radius is 2% and for the height is 4%. So we have to find the maximum percentage error for the volume. So as we know that the volume is pi r squared h. So for the partial differentiation of volume over partial differentiation of radius is equal to 2 pi r h. So for the partial derivative differentiation of volume over partial differentiation of height is equal to pi r squared. So for the we got the equation that delta v equal to partial differentiation of volume over partial differentiation of radius times delta r plus partial differentiation of volume over partial differentiation of height times delta h. So the then we put the then put the value into the equation. So lastly we got the maximum percentage error in the volume is 8%. So next for the question 2 is at an Oregon fiber manufacturing facility, an analyst estimates that the weekly number of pounds of acetate fibers that can be produced is given by the function. So for the question is z equal to fxy equal to 12,500x plus 4,000y plus 7x power of 2y minus 5x power of 3. So for the z is the weekly number of pounds of acetate fibers. So for the x is the numbers of skilled workers at the plant. So for the y is the number of unskilled workers at the plant. So for the question 2.1 is find the weekly number of pounds of fiber that can be produced with 11 skilled workers and 36 unskilled workers. So since the equation already given the equation, so we just have to put the value of 11 for the x value into the equation and for the y value into the equations. Okay, so for the next question is find an expression fx for the rate of change of output with respect to the number of skilled workers. Okay, so a new equation for the skilled workers, which is x1. So we have to differentiate from the first equation being given, differentiate it but in respect of x. So we get fx equal to 12,500 plus 14xy minus 15x squared. So for the next question is also same like the first question one, but we have to use the equation from the previous question, and then we just have to put the value into the equation, then we got the answer. So also same for the next question, for the 2.4 question, it is also same like the 2.2 question, but it is respect to y. Differentiate the y, and then we've got fy equal to 4,000 plus 7x squared. So for the next question, also same like the 2.3 question, we just have to put the value into the equation that we got from 2.4 question.
Assalamualaikum, my name is Nurul Nadia. My metric number is 8F200097. Okay, so this is the problem statement for number 3. Okay, we can see this is the formula for ideal gas law. We consider P as the output, while T and V, temperature and volume, as the input. Okay, so and R is the constant. Okay, so and R is already given. It is 1 and 8.31. Okay, so first we should find the pressure with respect to the temperature and pressure with respect to the volume. Okay, so to find the rate of change, we should use the first derivative. So to find the dp/dt, we just ignore the v, and then we just derive the t, and then we got r over v. For dp/dv, we just derive the v, and we ignore the t, temperature, and then we got negative RT over V power of 2. Okay. And then we can evaluate both derivative at temperature 300 Kelvin and volume 10 liters. Okay, so we just substitute all we got into the dp/dt and dp/dv. So for dp/dt, we got 0.831, and for dp/dv, we got negative 24. So for what we calculated just now, so we can make the conclusion. Okay, so for the dp/dt 0.831, we can make the conclusion. For each increase in T temperature, we expect pressure to increase by 0.831. Okay, while for the dp/dv negative 24, we can conclude for each increase in volume of 1 liter, we expect the pressure to increase by 24.9 kilopascal. Okay, it is decreased because the dp/dv we got negative. Okay, after that we move on to the problem statement number 4. Okay, so the question is find the rate of change or volume of the right circular cone with radius 10 cm and height centimeter if the increasing rate of radius is 1.2 cm per second, meanwhile the decreasing rate of height is 5 cm per second. Okay, for this question, we should use the chain rule to find the rate of change of volume. Okay, to find the rate of change, we should use the first derivative. Okay, so the RDT, we already got from the question. It is 1.2 cm per second, while for the HDT also we got for the question, it is negative 5 cm per second. Okay, to find the dV/dr with volume with respect to the radius, we use the formula of the volume of cone. So the volume of cone is 1/3 pi r power of 2 height. So we calculate the dV/dr, derive the volume formula for dV/dr. So we ignore the height and we just derive the radius only. So we got 2/3 pi r height. Okay, after that for the dV/dh we just ignore the radius and we derive height, and then we got 1/3 pi r power of 2, and then we substitute all the answer we got into the general formula. Okay, and then after we calculated it, we got the 73/3 pi centimeter cube per height.
So for the figure table that has been listed from the problem statement that consists 4 questions. That how we solve the problem and get the solution of the calculation. So the first question is to find the maximum percentage error in the volume. So this information will be used to develop the chain rule and get the general solution for the chain rule. So the action that we solve is to find information using note and study through mathematics engineering. The second question is to find the weekly number of pound of fiber that have been given for the equation, and then we have to find the rate of change of output with respect to the number of skilled and unskilled workers. So the idea is this information will be used to develop first order partial derivative. For the learning process is how we develop and evaluate first order partial derivative for function of to the variable. And then the action that we have to solve is find the general solution with partial derivative and substitution. So the third question is to find the ideal gas law with the pressure as a function of temperature and volume. And they have been given the formula. So this information will be used to develop the first order partial derivative. For the learning process in how we evaluate the first order partial derivative. And the action that we have to solve is finding all the information by using the basic or partial derivative. The last question is to find the rate of change of the volume of a right circular cone. So this information by given the formula of the circular cone will be used to develop the chain rule. And the learning process to get the general solution in the chain rule. For the action that we have to find to solve this question for is find the general solution and then find the differential equation by using the chain rule.
The conclusion for this project is, based on this group project, our group gained more knowledge on how to solve the problems regarding using the partial derivative method. Based on this method, there are a few types of partial derivative, which is first partial derivative, second order partial derivative, and higher order partial derivative, which is referred to third, fourth, or even higher partial derivative. Based on the problem statement, it can solve by using the partial derivative. It can calculate by using the method by using a formula with easier and simple. From the problem above, partial derivative can be used in our daily life applications. The equation also abound in all branches of science, engineering, and many areas business. That's all from us. Thank you.